Right, so this is Integrated Science 2023 external. So if you're new to this channel, kindly subscribe for more videos like this, okay? So specifically, I'm going to answer question 10, which is coming from materials and energy. Okay, so follow me suit as I'm explaining, okay? So this one is also likely to come in your exam for internal. It is going to come. Now the different one. They are going to twist the questions. So follow me suit as I'm going to explain or elaborate everything here. So the question is saying the following diagram shows an electric circuit with resistors M and N of equal resistance connected to a 6-volt battery. So now let me repeat on this part here. They are saying resistors M and N, and they're having what? Equal resistance. So as for resistance, we use capital letter what? R to represent what? Resistance under Ohm's law. Under what? Ohm's law. So an instrument which measures what? Resistance. It is called what? A resistor. Okay. Now resistor M and resistor N, they are having equal what? Resistance. So let's have an example. If the total resistance of these two, it is 20. If the total resistance of these two resistors is 20, then they are saying, let me say 20 ohms. Yeah, 20 ohms. Since resistance is measured in where? In ohms. So let's have an example, it is 20 ohms. For us to know the resistance of each resistor, we need to divide 20 ohms by what? By 2 to know the resistance of M and N. So in this case here, we can say resistor M is having 10 ohms and also resistor N is having what? 10 ohms. That is what? The interpretation of this statement here. Then let's move on to the circuit diagram. This circuit diagram is having what? Cells. It is having what? Cells. Now how we count the number of cells here is like this. You need to count the longer line and also the smaller or the shorter line. So the longer line and also the shorter line, they are going to make up what? One cell. The longer line and the shorter line, they are going to make up what? One cell. Is what? One battery cell. So in this case here, we are having how many? If you were to count, we are having 3 cells. How many? 3 cells. Then as for A, as you can see, this instrument A, it is called what? The ammeter. The what? The ammeter. Ammeter is usually denoted by capital letter A. Apart from that one, ammeter measures what? Electric current. Ammeter measures what? Electric current. So as for electric current, we use capital letter what? I to denote electric current. And usually electric current is measured in amps or amperes, denoted by capital letter what? A. So whenever we see a number like the way 2 is 2.0 amps or 2.0 A, which is capital letter A, that one is going to denote what? Amps for current. Then as for as for L, this L here, it is called the variable resistance. The what? The variable resistance, or we can say diostat or variable resistance. That is what? L. Then as for M and N, these two are what? Resistors. Now these two resistors, they are connected in where? In series. In what? In series. These two resistors are connected in where? In series. So resistors can be connected in series or parallel. Now so this one here, it is connected in what? In series. An example of resistors connected in parallel is like this, the one I've displayed on the screen. So it is this one here. Okay. So now let's try to answer the questions. Let's try to answer the questions. So now before I try to answer the questions, let me also give you the last one, the last point that you need to know. So in this part here, as for you grade 9s, they bring questions under Ohm's law. Under what? Ohm's law. They bring questions under what? Ohm's law. And also you need to know how to state Ohm's law. So Ohm's law states that provided that the temperature remains constant, the potential difference or the voltage is directly proportional to the current. Let me repeat. I'm saying, provided that the temperature remains what? Constant. When you say temperature remains constant, which means the temperature is not going to change. So provided that the temperature remains constant, the potential difference, also known as what? The voltage, is directly proportional to the current. Okay. So the first one, which is question A, is saying identify instrument what? L in the circuit. So instrument L is what? The rheostat or variable resistance. Rheostat or variable resistance. Then as for B, what is the total number of cells in the battery? What is the total number of cells in the battery? We said there are many? 3. So just say 3 cells. Then as for C, C is saying how are the resistors? How are the resistors M and N connected in the circuit? They are just asking you how they are connected. Are they connected in parallel or series? Here I was saying they are connected in where? In series. Simple like that, eh? Yes. So I'm going to say connected in series or series pattern. Then as for D, D is saying calculate the total, which is Roman. Calculate the total resistance in the circuit. So like I was saying, here they are going to bring questions under what? Ohm's law. So here I'm going to display a magic triangle. So this magic triangle is like this, okay? So you have V. This V here, it is representing what? Voltage. Then as for capital R, is representing what? Resistance. Then as for capital I, it is representing what? Electric current or just what? Current. Now in this case here, voltage is measured in volts. Resistance is measured in where? In ohms. Then current in what? In amps. Okay. So for me to calculate the what? The resistance, I'm going to use what? The magic triangle. So I'm looking for capital R. So in this diagram here, I've been given the voltage, which is what? 6 volts. And also the what? The current, which is what? 2.0 amps. So I'm going to say, if I want to find resistance, I need to add what? I need to add resistance. Then I'm going to find that the formula for calculating the resistance is going to be what? Resistance is equal to what? Voltage divided by what? Current. So in this case here, we are looking for resistance. So I'm going to say resistance is equal to voltage, which is what? 6 volts. So when you're calculating, don't forget to put what? Units. 6 what? Volts. Divided by current. So in this case here, the current is what? 2.0 amps. Then our final answer here is going to be what? 2 into 6, I'm going to get what? 3.0 ohms. Since here we are calculating the resistance, so we need to add the units, which is what? Ohms. Okay. Then as for Roman numeral number 2 is saying, calculate the resistance of resistor what? M. The resistance of what? Resistor M. So now, on this part E, you are going to find that since these two, they were saying they are having what? Equal resistance. They are having what? Equal resistance. And the total resistance here is what? It is 3. So here I'm going to say, since I'm having two things, for me to know the resistance of what? Resistor M, I'm going to say 3 divided by what? By 2. Then the answer is going to be what? 1.5 ohms. The answer is going to be 1.5 ohms. Okay. Then the last one, which is E. What would happen? What would happen to the total resistance in the circuit if both the voltage and current are doubled? So it's more like when you double the current. So since this one, the current here in the circuit diagram is what? Is 2. So when we double it, we are going to find that this is going to be what? 4 amps or 4.0 amps. Then as for voltage, is going to be what? 12 voltage. So now, let's try to find out the resistance. We are going to say resistance is equal to what? Voltage, which is 12 volts, divided by what? Current, which is what? 4.0 amps. Then the resistance here is going to be what? 3.0 ohms. So here we can conclude that the resistance is going to remain the what? The same. Remember, on question D, Roman numeral number 1, the answer is what? 3.0 ohms. Then we double the what? We double the voltage and also the current. It is giving us what? The same answer. Which means this one here, it is obeying what? Ohm's law. Because Ohm's law states that provided that the temperature remains constant, the current is directly proportional to the voltage, or the potential difference is directly proportional to the current flowing in where? In a conductor. Thanks for watching.